Hi everyone, and welcome to this new class in performance, and specifically we will be talking about range. So first of all, what is range? Range is simply defined as the maximum distance which an aircraft can actually fly from one point to another, from takeoff to landing. So range is a distance, and ranges may vary depending on the aircraft and the design of the aircraft, from 500 to 1000 kilometers for little aircraft, up to 15,000 kilometers for very long range aircraft. Now there's also a lot of aircraft which are around 6 to 8,000 kilometers in range, which is a normal operational range, But if we need to travel from a very long distance, then we need to ensure that our aircraft can actually have a very long range, such as 15,000 kilometers. So I want to talk about payload range diagram, because this diagram is actually commonly used in daily operations in many different operations for aircraft, and is actually controlled by the pilots themselves. So it is important to note, that depending on the range that we want to achieve for one specific flight, we may not be able to carry all the payload that we want. Now, what I mean by this is that if we are traveling very little distances, say like from 0 to 2000 kilometers maybe, we will be able to transport all of the people, or we will be able to actually fit all of the people that want to go on the aircraft, and there will be absolutely no problem. However, if we want to take all of these people to a very long distance, some of them will probably have to stay at the airport, right? Because if we want to cover for very long ranges, the aircraft may need extra fuel, and this extra fuel may imply that we need to reduce the payload. So let's talk about this very slowly, with different elements that are important. In this case, in this diagram, I want to point out three main parts of the diagram. The first one, as you can see, is a constant payload. The second one is the payload being reduced due to the increase of range, So this implies that less people will be able to go on the airplane because we want a larger range. And finally, we will talk about the limit, in terms of the maximum fuel and how much people can actually go on the aircraft. Right, so first of all, in this part over here, what we have is maximum takeoff weight, which, as we defined before, is the maximum mass that an aircraft can have, or that an aircraft can carry at takeoff. So this is a design limit. When you have designed an aircraft, you have a specific maximum takeoff weight. And this means that the pilot will not have the opportunity at all, in no case, to exceed the maximum takeoff mass, because it could imply, for instance, some structural struggles. And of course the pilot will not risk at all, structural damages on the aircraft. So the maximum takeoff, as you can imagine, is actually given and is constant and cannot be exceeded at all. So, in this case, in order to cover this range, in the case of 0 kilometers, you will need zero fuel, right? If you want to cover 2000 kilometers, for instance, in this aircraft, you will need more fuel. Not a lot of fuel, but, more fuel than zero. If you want to cover 4000 kilometers, you will need an increase of fuel, 6000 kilometers, whatever. There will be a point, where the amount of fuel that you need is actually limited by the maximum takeoff mass and the maximum payload. So what I mean by this is that there will be a point when the maximum payload cannot withstand, summed with the maximum fuel, the maximum takeoff mass. So let me explain this in another way. Maximum takeoff weight is constant, and as you can see, when we increase the range, we increase the amount of fuel that we need. So there will be a point when the fuel is enough that summed to the maximum payload is equal to the maximum takeoff mass. So okay, so this is what we have here, right? The maximum takeoff weight will actually be the maximum payload in all of this case, plus the fuel for all of this range, right? So for this part, we will get to a point where the amount of fuel summed to the maximum payload is the maximum takeoff mass. So in this case, in this point, you see that in order to increase the range, we will have to continually increase the amount of fuel that we need. So it's just a relation between the range and the amount of fuel. It is completely proportional, okay? Increasing the amount of range from this point on implies increasing the amount of fuel. And because the maximum takeoff mass is constant, if we want to continue increasing the amount of fuel, we will actually have to decrease the amount of payload. So this implies point 2. In this case, what we have is that maximum takeoff weight is actually maintained, but with a decrease of the amount of payload, okay, of the payload weight. And this implies that not all passengers will be able to travel with this aircraft if we want to continue increasing the range. Because if we were to transport all of these passengers, we would not be able either to fulfill the maximum takeoff weight or to fulfill the range that we want to achieve, right? So the idea is that the payload starts reducing due to the fact that we need to increase the amount of fuel, but the maximum takeoff mass has to be constant. So it's just that. Less passengers will be able to go on the airplane because the mass of these passengers will be substituted by fuel. So by continuing this and throughout 2, we arrive to a specific point where we already have maximum fuel. So in this case, in fact, we have all the deposits, all the tanks, all the fuel tanks completely full. So we cannot continue to increase the amount of fuel that we have. As you see, the maximum takeoff mass is actually constant, as we mentioned before, and maintained because we have reduced the payload in order to increase the fuel. However, in this point, we cannot, if the maximum fuel is already maximum at this point, you can see that throughout 3 we will have maximum fuel. Okay, so in this case we continue to have maximum fuel. And your question may be, well, you know, the range is related to the fuel. So if in this case we get maximum fuel, how do we continue to increase the range? So the idea is that we can continue to increase the range by reducing even more the payload. Okay? So again, this point is maximum takeoff mass and maximum payload. However, when we have to continue increasing the fuel, then we have to reduce the amount of payload in order to maintain the maximum takeoff mass. Okay? We continue on this curve over here, which is 2, until we get to the deposits being completely full. In this case, maximum fuel is achieved, and we can only continue to increase the range by reducing the weight of the aircraft. And reducing the weight of the aircraft, since the aircraft will be structural and you cannot, take pieces out of the aircraft, what you have to do is reduce the payload. So the maximum range, by definition, will actually be defined by no payload at all. Okay, so maximum fuel and no payload. This is the maximum range of an aircraft. However, this is not practical, as you can imagine, because you need to transport some people. So for most cases, you will probably be flying on this part of the payload range diagram, okay, in part 1. And for extreme cases, you can actually limit the amount of passengers that you will transport in order to get to higher ranges. Okay? Now, let's continue. Here are some of the examples of different ranges of different aircraft. Here you have, for instance, the Boeing 777-200LR. LR stands for long range, as you can imagine, And I believe this one is the highest range aircraft up to now, right? The range is 15,844 kilometers. Now it's interesting to note that the perimeter of Earth, okay, so going around Earth one time, is actually 40,000 kilometers, more or less, give or take. So this means that with this kind of range you can almost get from one point to any other point of Earth, okay, within a distance of 15,000 kilometers, which is very practical and is actually very interesting and can be used for many different purposes. Okay, if you want to go from the United States to China, probably you'll need a high-range aircraft such as the Boeing 777-200LR. What else? You have the Airbus A320, or rather the Boeing 737, which are quite similar, with a range around 6,000 kilometers, depending exactly on the model, depending on other characteristics of the aircraft. So this aircraft can actually perform well for different distances, but if you want to go from the United States to China, you may be limited due to the range. Okay. And here you have another model, which is, you can see, is a little aircraft. In this case, the range is around 1,000 kilometers. So this means you could cover distances in the United States. For instance, you could go from one city to another, but you can't go probably outside of the United States. Okay. Depending on where you are, of course, but the range is quite limited in this kind of aircraft. Now, this is a map. I wanted to show you a little map, okay, of different distances. And as we mentioned before, in comparative terms, this distance over here would be something like what an Airbus A320 or 737 could actually go, right? So the range of commercial aircraft, a normal commercial aircraft, would be actually limited by this distance, right? So you could go, for instance, from New York to Barcelona, and you can actually get from one point to the other with an A320. It's probably not the best solution because it probably would imply a reducing of the payload, okay? But you can get a rough idea of how range is related to actual distances in real life. Now, another interesting topic is that this would be around 6,000 kilometers, if I'm right. So we saw that an aircraft is long, the 777-200LR is capable of 15,000 kilometers. So this is roughly 3 times this distance, right? So you could almost get right to the, to Japan, whatever, on this direction, and also you could get to Japan on this direction, right? So you can see that probably you will be able to cover any point on Earth, given a certain range for an aircraft, right? So it's 15,000 kilometers. You'll probably get from any point to another point of Earth. So that's an interesting topic. You also have that little aircraft such as 1,000 kilometers would cover some distance like this. Of course, you have to take into account that Earth is not flat. Okay, Earth is not flat, guys. So you will go from probably, you can go from New York to some point in Canada from the north, okay? You can go to any point of, Brazil, whatever, and that will also, these routes will be defined, these distances will be defined by the geometry of Earth. So this is why you don't have perfect circles, okay? So I guess this is all for the range. We can go to the next topic now.